Okay, guys, so good morning. The limits that we did on Friday or Thursday, whenever the last time we saw each other, was they didn't have a denominator. So now we've got limits that have a denominator. And we've got to look at each one individually. I have added the graph so you can see what I'm talking about when I do these, and we're going to do 6 of them. So you'll have plenty of examples so you can do your homework. So on the first one, if you notice, they want to know what this graph does as x approaches 1. So if you look on this graph, the 1 is the asymptote. It's the part that the graph doesn't really touch. So when it approaches 1 from the left, it goes up to positive infinity. And when it approaches 1 from the right, it goes down to negative infinity. Well, since they go in different directions and you can't decide what the limit is, it does not exist. Now, if you also realize, if I were to factor, I can't factor any of that and cancel anything in that equation. When you can cancel, then it does something differently. So let's look at the second one. The second one, I'm going to move this up a little bit, is you've got upstairs, you've got x plus 1, and downstairs you have x squared plus 4x plus 4, which actually factors as x plus 2 squared. And we can't cancel the basement. And again, you are asking for the limit as it approaches negative 2, which is the asymptote. But in this case, both sides of the graph face to negative infinity, so the limit is negative infinity. What they're telling you is that as x approaches negative 2, we know it can't be negative 2 because that would make the basement 0, but as it approaches negative 2, both sides of the graph approach negative infinity. So that's why that limit is negative infinity, because they both go down. If they were to both go up, it would be positive infinity. So this next one, we have an x minus 5 upstairs, and I'm going to go ahead and factor the downstairs, and it's going to be x minus 5, x minus 3, because negative 5 and negative 3 equals 15, and negative 5 plus negative 3 equals negative 8. And in this case, these go ahead and cancel, so we would end up with 1 over x minus 3. And they're asking us to plug in for 5. So where 5 is right here. We do see a donut, because even though the x minus 5 canceled, we cannot have a 0 in the basement, so 5 can't be 0. But in this case, we could just plug in a 5 and get an answer. So we have 1 over 5 minus 3, and that does not give us a 0 in the basement, so that's 1/2 would be. But there's a minus sign in the front of this equation right here, so it'd be a negative 1/2. So that would be your limit as x approaches 5. Since the 5 canceled, we can actually find the limit. It doesn't mean it's defined at that point, but the graph gets really close to negative 1/2 when x gets really, really close to 5. And that would be like 4.99999 or 5.00001, okay? It would get really close to 1/2. Now this next one, number 4, we have also another discontinuity. We have an x minus 2, and x squared minus 4 is x plus 2, x minus 2. And they are asking, these two would go away, so we no longer have a 0 in the basement. That would be 1 over x plus 2. And we would plug in the 2, and that would be 1 over 4, which is 2 plus 2. So that hits 1/4. So you know that the limit is going to be where that donut is. You know it's between 0 and 1, but you've got to figure out what is the fraction. So when you see that they want you to do the limit at the point where the donut is, then you know you're going to get an answer and not does not exist. The next two, if we factor these, we get an x minus 1 and an x minus 5 squared. So we can't cancel anything in the basement. And they do want to know what happens at the asymptote. So in this case, the graph goes up on both sides of the graph. So the limit is going to be infinity. It's going to go to infinity. Those arrows are going to get closer and closer and closer and closer to that asymptote, but way up, and no matter how high the number gets, it's going to be still not quite 5. So the answer to that one would be infinity. They both go up. In this next one, they want us to find what happens here as x approaches 3. We can't cancel anything. 3x over x minus 3. Nothing can be factored. Nothing can be canceled. You can't cancel the 3's or the x's. You all know that. So in this case, one of them faces upwards to infinity and the other one faces downwards to negative infinity. So it does not exist. Now, sometimes they ask you for limits from the right or from the left, and in that case, there would be an answer to this, and we're going to do those tomorrow, so you're going to see the difference. We're going to do that, and then we're going to do infinity limits, and then we can have a little quiz on limits and be done with limits. I'll see you later. You'll have some notes in your Google Classroom of things to do today, so I'd appreciate it. Thanks. Bye. We're Zooming in a little bit.